So, hello everyone, hello everyone, and welcome to today's webinar. My name is Pragyanshu Jha, and I will be a speaker for this session. This session will be related to command injection, how we can automate its testing using powerful tools such as Commix. First of all, thank you for joining. Whether you are a security enthusiast, a student, a developer, or someone working in cybersecurity, I promise you'll walk away today with a clear understanding of what command injection is, why it is dangerous, and how attackers exploit it. This session will be interactive, so feel free to engage in chat if something interests you or surprises you. Trust me, some parts will. We'll also be doing a live demo because cybersecurity without hands-on examples is like learning driving by reading a book. It doesn't work. So let's get started. By the end of this webinar, you'll not only know how command injection works, but also how to detect, test, and defend against it in a safe and ethical context. So before we dive into topic, let me quickly introduce our narration, which is behind this webinar. Texas Technology Private Limited. We are a certain associated ISO 2001 certified cybersecurity company, and we have been working in this space for around 12 years. Throughout this journey, we have worked on multiple industries such as banking, fintech, healthcare, manufacturing, oil, gas, and many more across India and also globally. So that's about our company. All right, here's what we will be covering today. We'll start with basics. What's command injection? Once we understand how the concepts will work and move into different types of command injection attacks, such as and how they are carried out. Then we'll talk about impacts and risks. Because once you understand how dangerous this vulnerability can be, the importance of detecting and preventing it becomes very clear. After that, we'll focus on tool we'll be using today, such as Commix, including what it is and how it is useful for penetration testing and security engineers. We'll go over some important commands, which is the fun part, live demonstration, where I'll show you command injection can be tested in a controlled environment. Once the demo is done, we'll quickly walk through real-world case scenarios, and finally, we'll discuss the defensive strategies to prevent command injection attacks in applications. At the end, we'll have a Q&A session, so stay tuned and feel free to make note of your own questions. Let's begin understanding by command injection what actually means. So let's begin with the core topic, command injection. Command injection is one of the most severe and high impact vulnerabilities. It occurs when an application takes user input and directly passes it to operating system without properly validating its that is type something, and that user input ends up being executed as a system command. Then the application is vulnerable to command injection. So why is this dangerous? Because instead of entering unexpected data, an attacker can enter malicious input like commands to list files, steal stored credentials, upload malware, or even take full control of the server. For example, let's say imagine a website asking a user to enter an IP to run a ping test. It's very simple. But if the developer hasn't handled input securely, the attacker could enter something like 8.8.8 per se IP and concatenate it with a system level command, such as cat etc password. And suddenly, instead of just pinging, the server ends up revealing sensitive system files. This vulnerability essentially breaks the trust boundaries between application and operating system, allowing attackers to escape intended functionalities and interact with system at a privileged level. This is why command injection isn't just a bug; it's a doorway to attackers to escalate privileges, persist inside system, move laterally, and cause massive damages. Now that we know what it is, let's take a look at its major two types of command injection. First is inbound command injection, and another is blind command injection. Instead of differences between them, let's recognize how attacker exploit vulnerabilities and how defenders should test for them. Let's first start with inbound command injection. This is the most straightforward and dangerous type of command injection. And the attacker sends malicious command and it immediately sees the result in the application response. For example, imagine typing a payload and instantly getting system output like directory listing usernames right on the web pages. It's fast, visible, and very easy for attackers to leverage. The response comes back directly. The attackers can chain multiple commands, extract simple file systems, install backdoors, or escalate privileges. The another type of command injection is out of band or oftenly known as blind command injection. In this case, the command still executes, but the attacker doesn't see the output directly. This makes it more challenging because there is no visible feedback. So instead, attacker relies on indicators, indirect indicators, such as server delays, using commands such as sleep. Another one is DNS callbacks, file write operations, and also response behavior changes. Blind injection requires more skill and patience, but it's just as dangerous because the attacker gets confirmation they can eventually execute full system commands remotely. So to summarize, in command injection gives immediate visible output while blind requires indirect verification, but both allow arbitrary system command execution. So as we have, as you can see in this flowchart that I have made, let's understand it. So the first, let's say in a web application, you find an input field, you enter a payload, and we have find a web application with a vulnerability, let's say, because we know we are testing for that. So there is an input field running, let's say, ping command or any other type of command where we enter our system level command such as who am I, users, or sysinfo, something like that. And what it does, there are three scenarios after that. First, if the application is secure, it will result in server error, return server error, or it will say that we are authorized for that. Otherwise, if it is a vulnerable endpoint, then what we can see is either it will show the response, such as if I say who am I, it will list my name or server's device name on the application web page itself. Otherwise, it will execute or we won't see. If we can get a direct response, it comes under the category of inbound. But if we are not getting the direct response in the web page, then we can check for out of band, that is blind. We can enter sleep commands and check if the server delays the response. Let's say if we are entering for sleep 10 seconds, then the server is replying after 10 seconds. If it is doing so, then it is vulnerable to blind command injection. So now that we have known how they work, let's look at why this vulnerability is so dangerous in the real world. So now that we understand the types, the natural question is why is command injection considered one of the most dangerous vulnerabilities? Well, unlike many other vulnerabilities that only affect small components of an application, command injection targets whole operating system itself, the base itself, which means attacker isn't limited to command application anymore. So with successful exploitation, an attacker can execute system level commands, access system configuration files, modify or delete system commands, install malwares, keyloggers or backdoors, move laterally across internal systems. In many cases, command injection leads directly to remote code execution, also known as RC, and that's one of the highest risk outcomes in the cybersecurity world. If the server is running elevated privileges like root or administrator, the attacker can gain full control of the machine, and once that happens, it's not just about hacking the website, it becomes a gateway to the entire network. This is why security teams take this vulnerability seriously and why it is ranked highly in owasp and cybersecurity assessment. Because a small input validation mistake can lead to a complete system compromise. With that said, the good news is there are tools designed to help identify and test for this vulnerability. One of the most popular tools, a powerful one, is Commix, which brings to our next part. So now let's talk about the tool we will be working with today, or the testers are using it widely. Commix is an abbreviation for Command X Injection Exploiter. So what is Commix? Commix is an open source tool created specifically for detecting and exploiting command injection vulnerabilities in web application. It's built for penetration testers, for bounty hunters, or security researchers, and anyone wants anyone who wants to assess whether an application is susceptible to OS level coordination. The best part is Commix automates everything from identifying injection points to running payloads and even gaining interactive shell. So you don't have manually to test dozens of payloads. So now we know what is Commix, and let's discuss why we should use Commix. There are several reasons for that. Number one, it is much faster than manual testing. No need to craft payloads yourself. Another one is it can detect and exploit injection points in GET, POST, cookies, and even HTTP headers. It automatically fingerprints the target operating system and environment. It can escalate the injection to an actual interactive voice shell inside legal testing environments. So instead of spending hours experimenting with payloads, Commix handles the heavy lifting first, making the testing more efficient. But remember, the tool is only for authorized environment. Using it without permission is illegal and ethical. So now that we understand why we use Commix, let's come to some of its key switches and parameters that make it powerful. So think of these switches as like shortcuts. They help you control behavior of the tool depending on what you have trying to achieve. First, as mentioned in the table there, is that is the dash URL. Okay. So this is where you provide the vulnerable URL that you want the Commix to test. Without this, the Commix doesn't know where to attack. So it's basically a starting point. Another one is data. If you are dealing with post requests such as login forms or search fields, these flags lets you specify the data body. Commix will then test possible injection point inside that data. Cookie cookies sometimes use sometimes let's say sometimes parameters pass through cookie instead of URL of forms. Within this, the flag Commix will inspect cookies, values, and injection opportunities. Another one is version. Now this is very interesting. If the injection is confirmed, this switch attempts to spawn interactive voice shell inside the vulnerable environment. Another one is post SSL. Here, when let's say when we are using or working with the HTTPS target, this ensures the Commix enforces secure communication. Another one is batch. It is very useful for because as this is one great for automation. It runs the tool without asking for user confirmation. Perfect for scripts, reporting, and reported tests. There are many more switches available, but these are the only ones that you will likely use in the most penetration testing scenarios. Now we have covered basic. I think it's time to move from theory to practice and let's see the tool in action. So we'll be moving to our demo, live demo. So, so we are using Docker to host DBWA, that is the open source lab and control environment that we can use for showing our demo here. So we have started its image from Docker, and let's log in into DBWA. So those of you who don't know about DBWA, it is a lab for learning purpose. So let's say we are creating a database. Uh, just wait for a few seconds. It will, yes, a new database created. As we can see here, many vulnerabilities that you can use to practice and learn. We'll be using command injection to show you this. So now, as per our today's agenda, we will discuss command injection. So as you can see, the interface is showing input field where we have to enter IP address and it will ping the device. So before discussing anything, let's just enter this IP and see what we are getting as a result. So as you can see, it is running a ping request. We are getting ICMP packets from that. 4 packets were sent, 4 packets are received. So what is happening here? It is sending ping request to the IP I have entered. So let's say if along with this IP, I can concatenate another command, such as I'm appending a new command. Let's say who am I? Okay. So if it is vulnerable, in case of inbound command injection, it will just show the name of user that is behind this system. Okay, as we have entered who am I. So the injection was successful. You can see that we can get the name behind the user behind this, that is www.data. It is the name of the user. So this confirms that it's here command injection because we are running the system level commands without actually getting or authorized for that. So for demonstration purpose, let's try a few more commands. 8.8.8 and let's say I am cat etc hosts. Let's wait for this to execute. Yeah, we have got the result back again at the web page itself. As you can see, we have it is mentioning many hosts that is inside that system. Another one we can run is we can read password files. See, these are typical system details that shouldn't be demonstrated or leaked at the web page. So this is a clear and quite a huge vulnerability because we are getting a good amount of idea about what is the system, what is Linux, what is this version and all. We can run different command tools, see other things. We can also get a reverse shell access here by just entering a command. It will start a reverse shell where we can get a code space and we can enter different commands. We can exploit it. We can compromise their system or potentially compromise the system, and we can do many more. We can chain attacks. We can do remote code execution and many things. So this is a clear case of inbound injection, inbound command injection. So this was about the demo. We are only showing this as a manual, but you can use also Commix for that. So let's get back to again theory. Just a second. Before, as we have seen in this demo, how an attacker does this actually. Before moving ahead, let's discuss a real world case scenario. For example, a real world example where command injection played a major role was the 2018 British Airways breach, which exposed personal and financial details over 3 lakh 80,000 customers. Just see the number 3 lakh 80,000 customers. Financial and personal details were leaked. The root cause was vulnerable script running on the server that accepted user applied input without proper sanitizer. Just a simple thing. But attackers have exploited this weakness to execute system level commands and inject malicious JavaScript into payment page. What this resulted in is that this allowed them to silently capture customer details, including names, address, card information in real time during transactions. The result, beyond the reputational damage, British Airways faced a regulatory fine of nearly 230 million under GDPR, all triggered by injection vulnerability that started from the proper handling of user control input. So that's why I'm saying maybe it is a very small thing, but that can be changed and exploited into a very big thing. So we need to be sure about how we are writing code, how we are sanitizing the input fields and all. So the takeaway is simple. One insecure parameter, just one, can compromise an entire business ecosystem. So now we have we have seen how command injection works, how dangerous it is, and how easily it can be exploited. The big question is how do we prevent it? The good news is the command injection is preventable with the right development practice and security mindset. Number one, let's say what's the basic thing is input validation sanitation. Let us never trust the user input, validate what is allowed, whether it's a character, format, length, or type. If the application expects an IP address, only allow digits and dots, not arbitrary characters. Use safe APIs and parameterized functions. Instead of sending user input directly to the system commands, use secure libraries such as APIs that don't allow command chaining. Also, avoid functions like system, exec, shell exec, or similar unsafe wrappers unless absolutely required. Another one is we can ensure the application runs with the minimum permission necessary. Even if the attacker breaks it, the damage remains limited in that scenario. We can also properly escape shell meta characters such as percent, greater than, less than, dollar, etc. This prevents attacker from injecting additional commands. Also, we should regularly use tools like Commix, Burp Scanner, or CI/CD based security testing to identify weakness early and before deployment. Finally, the development teams, most command injection vulnerabilities happen not because the developers are careless, but because they assume their application won't receive malicious input. So, security is not just a tool, it's a habit. And with that, we are almost at the end of the session. So, all right, that brings to our end of session. I hope this webinar gave you a clear understanding of what command injection is, why it is dangerous, how tools like Commix can help identify these tests, vulnerabilities in a structured and ethical way. Remember, security isn't just about hacking or tools. It's about mindset, awareness, and prevention. A single unhacked, or I will say a single unchecked input field can become a doorway to full system compromise. But secure development practice can close that door before attacker even. So thank you all for your time, energy, and participation today. I appreciate you being here. If you have any questions, feel free to ask. I will stay here till some time. Here. You can enter your doubts or queries in the comment section. I'll be sure to answer that. And you can also reach out to us later through email, LinkedIn, or follow discussions. We are open for learning paths, internship queries, and collaboration. Once again, thank you. Stay safe, take care, and keep securing the web. Okay. So thank you for your time and energy and participation today. I appreciate you being here. So stay safe, stay secure, and keep securing the way. Thank you.